Welcome back, Geometry Scholars. Today's lesson is on reflections, rotations, and investigating symmetry. Our essential question for this lesson is how do transformations help identify and prove congruent or similar figures? And our objective for today's lesson is that you will be able to rotate and reflect figures as well as finding line and rotational symmetry. So let's go ahead and get started. And a lot of this will be review. The last couple of lessons we've been talking heavily on transformations. So this should be pretty easy for you, as well as we've been including in our bell works. So first of all, let's remember that reflections are what kind of motions? Hopefully you remembered that they are rigid motions. And what does rigid mean? Rigid, they're not changing shape or size, staying the same shape or size. So here are some rules for reflections on a coordinate plane. You can see them right here. We have referred to them many times. I would say let's go ahead and highlight this in blue or yellow or whatever color you want to highlight it, so that way you can refer back to it when we are trying to do transformations. One I want to point out to you, and we talked about it in a previous lesson, is this one right here where it says xy becomes yx. So that line would be, for example, 0, 0, 1, 1, 2, 2, so on and so forth. So that would be this line right here. This is the y equals x line, because here's 0, 0, here's 1, 1, here's 2, 2, here's 3, here's 0, 0, here's 1, 1, here's 2, 2, 3, 3, and so on. That's the y equals x line. And I'm going to write that right here. This is the y equals x line. So the y equals negative x line is the opposite of that. So that would be this way. Okay, the opposite signs. And this is the y equals negative x line. And we'll get it. That should actually be a review from algebra. I just want to draw that out for you guys. Go ahead and write that on your paper as well. So that's what that line is. Okay? Moving on, perpendicular lines have negative reciprocal slopes. Negative reciprocal slopes. Now, I hope some of you remember what negative reciprocal means. Negative means the opposite sign. Reciprocal, it's upside down. So, for example, if we had the slope of 5 over 1, the negative of that would be 1. The negative of that would be the negative sign. And 1 over 5 is the reciprocal. So together we have the negative reciprocal, negative 1 over 5. If we had the slope negative 2 over 7, the negative reciprocal then is the opposite sign. So the opposite sign, which would be positive, and then reciprocal 7 over 2. So if I gave you the slope of negative 3 over 6, what would the negative reciprocal slope be? Hopefully you said it would be a positive 6 over 3. So it goes up, flips upside down, and it's the opposite sign. Okay? Those are perpendicular lines. Lines that are perpendicular to each other have negative reciprocal slopes. Perpendicular lines create, the intersection of the perpendicular lines create right angles, okay? And their slopes are negative reciprocals of each other. We need that information because we can use the slope of perpendicular lines to help us reflect across any random line. So up until this point, we've been reflecting across line X or line Y. But now we're going to learn how to reflect across any random line. So what I want you to do is we're going to start with point C, and we're going to find the slope until it crosses line L. So it's already on line L, and so we're going to count up and over, rise over run, until it crosses line L again. So up 1, and then over 2. So the slope of that is 1 over 2. Well, because we're dealing with perpendicular lines and such, we need the negative reciprocal slope of that. So the negative reciprocal slope that we'll actually be using is negative 2 over 1. So we're going to be using the negative reciprocal slope of negative 2 over 1. So I'm going to start at point A, and I'm going to use the negative reciprocal slope, so down 2, because it's negative, over 1, and I use the slope one time and connected with line L. So since I used it once to get to line L, I only have to reflect it one more time. So down 2 over 1. So here is A prime. So now let's go to point B. Down 2 over 1. Am I on line L yet? No, I'm not. I need to keep using the slope until I'm on line L. So down 2 over 1. So I had to use the slope 2 times to get to line L. So since it took me 2 slopes to get to line L, the same thing happens right here. I'm going to start at line L, down 2 over 1, down 2 over 1. Here is B prime. Okay, I'm going to erase some of this so it doesn't all get too messy here. I think you guys get the point though. So here's A prime, here's B prime. And then where do you think point C is? Where do you think point C should be? Hopefully you said it's actually going to stay there on line C, and you are correct. It is. So I now have the 3 points. I have A prime, B prime, and C prime. Again, I started at C and I went up 1 over 2. And that was to to find the slope from one point to the next, so up 1 over 2. But then I needed to use the negative reciprocal slope. I'm kind of like working backwards. And the negative reciprocal slope was negative 2 over 1. So I started at point A, went down 2 over 1 and landed on the line. So then went down 2 over 1, found A prime. B, started at point B, had to go down 2 over 1 twice until I landed there. And so then again, down 2 over 1, down 2 over 1 twice until I landed here. And then C stays the same. And here is my new shape that I have reflected across a random line. So not difficult. The only thing you have to remember is that we're using a negative reciprocal slope. Okay, this is a reflection that we have, something that we should feel very comfortable with. They already gave us the points. We're going to reflect the figure with the given vertices across y equals x. And looking back at the notes that maybe you highlighted, when we're reflecting it across y equals x, we are simply switching the points around. Okay, so go ahead and please rewrite D prime, E prime, F prime, and G prime. Go ahead and write your notes. Go ahead and write your points for those coordinates, please. Okay, hopefully you wrote these coordinates down, 0, 2, 2, 2, 2, 5, and 1, 5. If you didn't, make those corrections. And then go ahead and I want you to draw the original figure, and then I want you to reflect it with the new figure. I'm going to pause the video and try that, please. So if you look at the screen, you can see that I have D, E, F, G graphed. Those are the original coordinates, and now you need to go ahead and graph the reflection. And we've already found the new coordinates by simply switching them around. Y equals x, so therefore x equaled y, and graph the new image, please. Okay, and there is the image of that object reflected across y equals x. Now, if you remember when I showed you back at the beginning of the lesson, y equals x is this vertical line running in this direction here and here. Not vertical line, I'm sorry, diagonal line running in that direction. So I told you it was 1, 1, 2, 2, 3, 3, and so on. So if I'm going to take this red pen and y equals x, that line runs at 1, 1. Okay, you can see this is at 1, 1. So it runs at 1, 1. It runs at 2, 2, 3, 3, 4, 4, 5, 5, 6, 6, and so on. So if I were to draw my line straight through these points, and I did this on my paper, and I'd like you to do that also. If you draw that line right down there, and then you take your paper and you fold it on that line, the pre-image, and then the image will lay right on top of each other. And I will show that in class as well, but if you draw this y equals x line, which goes right down the middle, and it actually should go kind of right through point 0. Definitely a little bit challenging. Okay, that's as good as I'm going to get right now. If you fold it right on that line, the pre-image will line up perfectly with the image. Okay, so that's reflection across y equals x. Moving on. Given that ABC is the image of triangle ABC, given that triangle A prime, B prime, C prime is the image of triangle ABC, under reflection, draw the line of reflection. So they're telling us that they already reflected it across the line, but we don't know how they reflected it across the line. We do know that the line of reflection is right in the middle of an object, okay? If it's a mirror image, it's got to be right, that mirror has to be right in the middle of it, okay? That line has to be right in the middle. So there's two ways of doing it. If I'm looking for the middle of 2 points, we can use the midpoint formula. So we need point A, which point A is at -3, 3. And then we need A prime, which is at -5. -1. And so a midpoint formula is x1 plus x2 divided by 2, comma, y1 plus y2 divided by 2. So x1 is -3 plus -5 over 2, and then 3 plus -1 over 2. -3 plus -5 is -8 over 2. 3 plus 1 is 2 over 2. Okay, -8 over 2 is -4, and then 2 over 2 is 1. So -4 and then 1 is the middle of A and A prime. So -4 1 is right there. Okay, so that line is the middle of A and A prime. So here's A prime. -2, 1 is right in the middle of A and A prime. So I know some of you are thinking, surely there must be another way I can do this, and you are right. You can also use the slope to figure out the line of reflection, and that's what I'm going to show you next. So I'm going to start at C, and I'm going to find the slope to C prime. So it went down 1, 2, 3, 4. Over 1, 2. Okay, so I had to go down 4 and then over 2 to get to C. Well, I'm looking for the middle of that. So what's half of 4? Well, Believe said 2, and half of 2 is 1. So I can also use 2 over 1 to figure out where my next point is. Again, I'm looking for the point that's halfway between C and C prime. So it was 4 down, 2 over. So halfway would be half of 4 is 2, half of 2 is 1. So I'm going to go down 2 and over 1. So down 2 over 1 is right here. And I can use that reverse logic to see. Let's look at A. Down 2 over 1. Was on the point I already thought it was. So I definitely did it correctly. You can use the midpoint formula to find the middle of 2 points, A and A prime, and that gives you a point. But we needed a second point because we needed 2 points for a line. You can also use the slope. It was 4 down, 2 over. Half of that is 2 over 1. And so here's my second point, and then simply draw your line, and here's your line of reflection. And it's an equal distance. A is an equal distance from the line as A prime, B is an equal distance from the line as B prime, C is an equal distance from the line as C prime. Okay, so again, as a recap, all I did was I found the midpoint. I used the midpoint formula to find the distance between A and A prime and plotted that point, which was -4, 1. Or you can use the slope and figure out what the slope between C and C prime was, and then what's half of that, okay? Half of 4 over 2 was 2 over 1, and that's the midpoint. Okay, moving on to rotations. A rotation is a transformation around point P, the center of a rotation. The angle formed is called, wait for it, the angle of rotation. What do you know? The angle formed is called the angle of rotation. And here are some more rules for rotating. And again, just like with the reflection ones, highly suggest that you highlight these because you are going to want them and you're going to want to refer back to them. Really, you need to memorize them, but at least highlight them for right now. So that way you can easily find them when I give you a rotation to find. You're like, but Mrs. Locke, what do I do? here's what you do. So commit those to memory. You need those. Don't forget it's counterclockwise, unless otherwise told. So example 4, draw the image of the figure under the given rotation. So quadrilateral ABCD, and it rotates 270 degrees, and remember, counterclockwise unless I tell you otherwise. So first of all, we need to know the points for A, B, C, and D. So go ahead and pause the video, and please find the points for A, B, C, and D. Hopefully you said A was at 0.02, B is at 0.14, C is at 0.42, and D is at 0.31. So now we are going to be, and we didn't have to guess those, we simply can use the graph and count where the points are and find that. So that should have been really nice and easy. Now we're going to use the rules that I just showed you to find a 270 degree rotation. So 270 degree rotation, the X and Y switch places, and now the second coordinate is an opposite sign. So we need A prime, B prime, C prime, and D prime. I'm going to do the first one for you. The X and Y change places, so now it's 2, 0, and the Y coordinate should be negative, but there's no such thing as -0, so you don't have to write -0. Okay, it should have been the opposite sign. So go ahead and find points B, C, and D, please. I'm sorry, B prime, C prime, D prime. Okay, hopefully you found A prime is 2, 0, B prime is 4, -1, C prime is 2, -4, and D prime is 1, -3. At this point, I'd like you to please graph the image. Okay, hopefully your graph looks a lot like mine. Hopefully a little neater. As you know, drawing on the smartboard is just so pleasurable. And so that's rotating at 270 degrees. Really easy as long as you know the rules. So as I've said many times, you have to memorize those rules. Moving on, lastly, investigating symmetry. A figure has symmetry if a rigid motion exists that maps the figure onto itself. A figure has line symmetry if a reflection maps the figure onto itself. A figure has rotational symmetry if a rotation maps the line onto itself. The angle of rotational symmetry is the smallest angle of rotation that maps a figure onto itself. Because obviously, if you draw any random crazy shape and you rotate it 360 degrees, it'll map itself onto itself. So we're looking for the smallest angle, something that has rotational symmetry of less than that, okay? So let's go ahead and do some examples. Number 1, does the figure have line symmetry? If so, draw its lines of symmetry. So shape A, does it? It sure does. Yes, it does. And it only has one right down the middle. Go ahead and please do lines. Go ahead and please do problems B and C. Problems B and C. Okay, shape B, yes, it does have rotational symmetry. It does have line symmetry. And it has 5 lines of symmetry. This is a pentagon, and because all the sides of the pentagon are equal, it has 5 different lines of symmetry. I started from each vertex and just drew a line to the opposite side. We had a problem like this in bell work, or similar to this in bell work, and it only had 1 line because the sides weren't all the same. But because all of these sides are the same length, and you can just kind of tell that by looking at it, it has 5 lines. In a perfect world, this shape would have had tick marks on all of the sides to show that it indeed all had congruent sides. But yes, it does. It had 5 lines of symmetry. And letter C did not have any lines of symmetry. Can't cut that in half anyway and make it even. Does the figure have rotational symmetry? If so, what are the angles of rotation? So does the square have rotational symmetry? Well, let's see if I can turn it. And I've only turned it 90 degrees. It was right here, turned it 1 turn 90 degrees, and it landed on itself. So again, landed on itself. So does it have rotational symmetry? Yes, it does. And what's the smallest amount that I have to turn it in order to find the angle of rotation? Well, in order to make it map up on itself, I have to turn it a full 90 degrees. I can't turn it any less than that for it to map onto itself. So 90 degrees is the correct answer. Letter B, does it have rotational symmetry? Let's try it. I'm going to turn it around. There it is. There it is. and so on. So yes, it does as well. What is the angle of rotation for this? Again, look, watch if you want to watch the green circle. I didn't have to turn it a full 90. Actually, when I turn it a full 90, it doesn't line up anyway. Okay. So the way I find this is it has rotational symmetry. I count the vertices. It has 1, 2, 3, 4, 5, 6. Well, 360 degrees is a full turn. So 360 divided by 6 is 60 degrees. So 60 degrees is the shortest amount I can turn it, smallest amount I can turn it for an angle of rotation. Okay, please find letter C on your own. And hopefully, so yes, it does as well with a 60-degree angle of rotation. And again, 360 degrees, there are 6 vertices, so it needed to turn 60 degrees. And let's see if I can still turn this. There we go. There's my 60. You know, you can tell it's more than 45. It's not quite 90. Put it back together. Okay, so hopefully that section should have been nice and easy for you guys because we've been doing that on bell work, and a nice review. So summary, don't forget to write what did you learn, or if you had any questions for this lesson, please make sure you write them there as well. Feel free to watch this video as many times as you need to, but again, this should have been a nice, easy review video. Thanks, guys. See you next class.